Hello everyone. So in this video, we'll be seeing a very important probability distribution which has got huge applications in various fields, right? That is normal distribution. So far whatever we had seen, that is binomial and Poisson, they both are discrete probability distribution. But in case if it is a continuous random variable like height, weight, salaries, wages, profits, sales, etc., then it is impossible to distribute the total probability among different mass points. It will not be a mass point, it will be a continuous, since between any two unequal values. For example, if I say how many values are in between, let's say 15 and 17. If I ask this question, how many values are between 15 and 17? Immediately, most of the people tend to give me an answer, one value, which is 16. But I never said that it is integers. I just simply said how many values between these two values. Means it becomes real numbers. So you will end up having infinite number of values, because even 15 point, I can say 15.000001 is also comes under this 16.99999. I can put any number of digits after the decimal point. So that also is a part between this range. So it becomes continuous in that case. So thus, a continuous random variable is defined in the form of a probability distribution, probability density function. We are calling it as f of x. So this normal distribution is basically a continuous probability distribution, and most of the real life situations can be modeled as a normal distribution, right? So it is also called as Gaussian distribution because it was first discovered by Carl Friedrich Gauss, right? He has first started discovering this and used it. So how the probability density function will look like in case if any random variable capital X is supposed to follow a normal distribution, means with having a parameters mu and the sigma square as mean and variance. This mu is your mean, and the sigma square is variance. And we denote it by X follows normal with the mean mu and variance sigma square if the PDF or the probability density function of the random variable X is given by f of X is equal to 1 by sigma root 2 pi e to the power of minus half into X minus mu by sigma the whole square. All this entire thing is there in the power, is in the exponent form. And the X value lies between negative infinity and positive infinity. It can go anywhere between that. Here this pi is nothing but 22 by 7, and this exponent is nothing but 2.718, and it keeps on going, right? So the name normal distribution has its origin some 200 years back, as the then mathematicians were in search for a normal model that can describe the probability distribution of most of the continuous random variables. So if we plot this function, if we plot this, means if I call this as y, let me say this is considered to be y, and for every value of x, whatever I allocate between negative infinity and positive infinity, I may get value of y. That means I can able to get this coordinates for each value of x. I can get a coordinate x comma y. And if I try to plot this on a graph sheet, if we plot this on a graph sheet, we will get a probability curve which will take a bell shape, and that will have only one peak, which implies that the normal distribution has a unique mode. Only single mode is there, right? So the curve will look like this. It will be like a bell curve going like this from here to here like this, and the center point is your mean, and this side it is negative infinity, this side it is positive infinity. This entire thing you call it as x-axis, and this is our y-axis. Right. So this will be the shape of a probability curve for a normal distribution, which is that is the reason it is also called as a bell curve distribution. You can also call it as a bell curve distribution. Another thing is you may look into this curve. It is actually symmetric on both sides. Means from the left side of mu, whatever is the area which is covered, it will be the same as the right side of mu. Means if I calculate the area from negative infinity to mu, that will be the same as mu to infinity. And for any probability curve, the total area is considered to be 1. That means from negative infinity to mu, it will be 0.5, and mu to infinity, it will be again 0.5. So that's what is said here. The curve in the slide reveals that the line drawn through x equal to mu has divided the normal curve into two parts, which are equal in all respect. That is why it is also called as a symmetrical distribution, because this is a symmetrical curve, symmetric on both sides exactly from the middle. Right? So hence normal distribution is symmetrical about mu. We may also note that the two tails, what they meant by tail is this tail. This is the left tail. This is the right tail. These two tails, sorry. Yeah. So note that the two tails of the normal curve extend indefinitely on both sides. Means this never touches the x-axis. This also, this tail also, this tail also. Never touches the x-axis and it goes to infinity. That's what is said here. Indefinitely on both sides of the curve, and both the left tail and right tail never touches the horizontal axis. And we already seen mean of the normal distribution is given by mu. And since it is symmetrical, all these will be the same. Means it coincides. Mean, median, mode, all will be equal to mu only. The standard deviation of the normal distribution is given by sigma. Mean deviation of a normal distribution is given by square root of 2 by pi times sigma, which is approximately equal to 0.8 times sigma. So it is easy to remember 0.8 times sigma. And the first and third quartiles of a normal distribution are mu minus 0.675 times sigma and mu plus 0.675 times sigma. Means if you add these two and then divide it by 2, you will get the quartile 2, which will lead to 2 times mu divided by 2. Again, it will land up with this mu only, right? So quartile 2 is nothing but the median. So again, whatever we spoke about, the total area of the normal curve is taken to be unity, that is 1. The area between negative infinity to mu is the same as the area between mu to infinity, which is 0.5. Since the normal distribution is symmetrical about x equal to mu, its skewness is 0. What do we mean by skewness? I mean, taking one particular side means, suppose I can also have a shape like this. This is possible. No, it is not like this normal. And it can also, if it is skewed, then you say it is like this. Either this side skewed or this side is skewed, right? That is not happening in normal distribution. It is symmetrical, right? It's skewness. These two curves, whatever I have drawn, is skewed curves. These two are skewed to one side. So that is not there in normal distribution. It is having 0 skewness. That is, normal curve is neither inclined towards the right nor towards the left. When the mean is 0, so this particular value, this mu, if it becomes this, if this is 0, then you call that as a, what do you call, sorry. If the mean is 0, then the area between negative infinity to mu is the same as area between 0 to infinity is equal to 0.5. And that is possible by converting this random variable x to a new random variable z, which is called as a standard normal variate. And the conversion factor is x minus mu by sigma. So by using this, we can convert most of the probability distributions to a normal, standard normal distribution. And that probability density function is given as 1 by square root of 2 pi, means that sigma is missing because sigma is 1 now. Here I can say mu is 0 and sigma square is 1, or sigma is also 1. So the sigma becomes 1, and here x minus mu, there that mu is becoming 0, sigma is 1. So that x, since I wrote it here as z, I'm converting that x to z, changing the variable in the function. So negative infinity less than z less than infinity. Here the random variable z is known as a standard normal variate or variable or a standard normal deviate. Why this conversion factor is very useful? Because if you want to find out a probability, you may have to use directly. If you are trying to do it, you may also use definite integrals. Integration you may have to use instead of using an integration. If I could able to convert this, then I can refer to what is called as Z tables to find out the probability, also called as area under standard normal distribution. So we can refer that particular tables to find out the value of, to find out the probability against a Z value, or if the probability is known, from that we can find out the corresponding Z value. And then from Z we can find out the desired X value. So most of the problems we'll be doing this conversion, means a normal distribution will be converted to a standard normal distribution. That we will be doing in most of the problems. And then we will refer to this particular tables to find out either the probability or given probability to find out a Z value, right? So that's all in this particular video. In case if you find the contents of this video to be useful to you, I request you to please share it with your friends and like the video also, and request you to subscribe my channel so that you get regular updates on my uploading of various videos. Thank you. Take care.